So we're in the middle of 9-3, and we did letter H. And so this whole set of problems, we got a few more like this, and we're finding the probability of dealing a hand of 5 cards. So if you play, I think euchre has 5 cards. What's another game that has 5 cards in your hand? That's about all I play on cards. So there are card games that you have 5 cards in your hand, and so we're just saying, what's the probability if you have 5 cards that these things happen? So the very last one we did, okay, what's the probability of dealing 2 tens, 2 jacks, and 1 queen in one hand? So we knew there are 4 tens, so we want 2 of them, 4 choose 2. There are 4 jacks, and we want 2, 4 choose 2, and there are 4 queens, 4 choose 1. We only wanted one of those. All of these are probabilities, so we're dividing all of them by 52 to choose 5, because there's a total of 52 cards, and we can choose 5 of them. Or else if we can't handle this, you're going to have to find new seats. Thank you. Okay, what's the probability of being dealt a 5-card hand with no aces, no queens, and no 5s? How many aces are there? 4. How many queens are there? How many 5s are there? 4. Good. So we don't want any of those. So how many cards can I not pick from? 4 plus 4 plus 4 is 12. Ooh, one of those days. One of those days. It's okay. I can't have 12 of them of the 52. At least you're paying attention, Brooke. Yeah. There are 52 total cards, and there are 12 that I can't pick. And those who aren't paying attention didn't even blink. I've got 40 cards that get to be chosen. I know. Don't make fun of me too much lately. So there are 40 cards that I can choose from if I don't want aces or queens or 5s. So that means that I have 40 choose 5 that I can choose for my hand, and it's divided by my total, 52 choose 5. Because that's what I'm dealing. So I want 5 cards in my hand. And so that's what all of these problems are. We're all dealing 5 each time. Now, if it was poker, I don't know if you've ever played poker, but poker is 2 cards. So you get 2 cards and then you do something with it. That's all I know about poker. But that's it. That's my extent of my knowledge. But so if we were doing a different game and you were dealing 2 cards or 10 cards, that would be a different 5 choose or 25 choose that many. So next it says, what's the probability of being dealt exactly 4 spades? So you have to have 4 spades. How many spades are there in a deck? 13, good. So there's 4 different suits and 13 of each one. So of the 13 spades, we want to choose exactly 4 of them. Now, that's only 4 cards. I need 1 more card to complete my hand. I don't just get 4 cards and I'm like, I'm not going to get the last card. If there are 13 spades, how many other cards are there? How many cards are left if I've already dealt with my 13 spades? 39. So then it's going to be 39, choose 1. Like we did up here with the jacks and 10s and queens, we're going to multiply those together. So I'm going to do 13 choose 4 times 39 choose 1. The reason we multiply is because that's all in one hand. That's one situation. That's one time that's true. In a minute, I'm going to show you what's different when we got 2 different hands or 2 different situations. Again, we're going to divide by 52, choose 5. Okay. The next one is an example of where I'm not going to just multiply. I'm going to have to do a plus in here. So it says, what's the probability of dealing at least 4 spades? So is it okay that I have 4 spades? Is it okay that I have 5 spades? Yes. So okay is 4 and 5. What's not okay? Can I have 3 spades? Is that okay? No. Can I have 2? Can I have 1 or 0? No. Okay. The reason I made a list of okay and not okay options is because you often just want to do the one that's smaller. If it's okay, you just do the probability of those 2 things and call it a day. However, if the smaller thing's the not okay, you can just do 1 minus the not okays, and then that could be easier. It's easiest here to do my okay, so we're going to do that. Lucky for us, the step above, we just found the probability of getting exactly 4. So this is the probability of getting 4 spades. So I'm just going to copy that back down. It was 13 choose 4 times 39 choose 1. Now you guys also told me it's okay if we had 5 spades. How do I see how many options there are to get 5 spades? How many spades are there again? 13. And how many do I want this time? 5. So we're going to do 13, choose 5. And all that's over 52, choose 5. I didn't have a multiply with my 13, choose 5 because that already hit all 5 of my cards. I didn't need to do anything else. All right. Do you guys remember why we're doing C this whole time and not P? Why are we doing C's, not P's? Order doesn't matter, right? You get all these cards, and it doesn't matter if you got the queen first or the spade next. It just matters that you have them all in your hand. So these are all order doesn't matter. Ooh. All right. Next one says, what's the probability of being dealt at most 4 red cards? Okay. What's okay here? Is 4 red cards okay? Is 5 red cards okay? No, because it says at most. You can't have more than that. That means my okay pile is going to be 4 and 3 and 2 and 1 and 0. If it says at most 1 red card's okay. If it says at most 3 red cards is okay. If it says at most 0 red cards is okay, but 5 is not okay. This time, I don't want to do my okays. It already took us a while and a lot of space to do my 2 different okays. If I have to list 4 okay options, that's going to be excessive. Let's do the not okays, and we're going to do 1 minus the not okays. Remember we did that the other day? We did 1 minus the not okays the other day? Because probability is 100%. So if I want the not okays, you just take all of it minus the little bit that's not worth it, and then that gives us the rest. So what's the probability that we're going to get 5 red cards? How many red cards are there? 26? And how many do I want? I mean, I guess maybe how many do I not want? 5, right? And what's not okay is 5 red cards. So 26 choose 5 is not okay. And we're still doing probability, so we still do the total underneath it. And again, when we do a review day, we can practice these. If you want to come see me before school or via Zoom, I can help you plug these in the calculator. But the setup is the most important to me. All right, the very last one of this type says, what's the probability of being dealt 2 of one suit and 3 of another? Okay, right now it doesn't matter what suits we're talking about. Let's just say I want hearts for my first suit and I want clubs for my second suit. Okay, what's the probability of being dealt 2 hearts? How many hearts are there? How many hearts? How many of one suit are there? 13. And I want to be dealt 2 of that. I want 13, choose 2. Okay. Then I want 3 of another suit. So let's say it's clubs. How many clubs are there? And how many do I want? 3. So I did 13, choose 2 for hearts. I did 13, choose 3 for clubs. And I'm going to do all over 52, choose 5. Now I'm not technically done. We're going to multiply it by something. You guys heard me say, okay, let's say it's hearts or let's say it's clubs, right? How many options did I have for the first suit that we had? I said hearts, but how many options did I have to choose from? 4, right? There's 4 suits. I'm going to put a number here, but there's a couple different ways of thinking about it. So I had 4 for my first one. Okay, once I chose hearts, how many options did I have for the second suit that I chose? 3. Good. I had hearts. I can't use hearts again, or else that would all be the same suit. So I had 4 suits to choose from for the first or 3 for the second. So the number that I'm going to write outside is 4 times 3, which is 12. Another way you could have thought it was using not my C's, but my P's. There's a total of 4 suits, and I want to pick 2 of them. I use a P here and not a C because order matters. Like, it's different if I want 2 hearts. That was supposed to be a heart, and then it went dry. It's different if I wanted 2 hearts and then 3 clubs. Oh, why did I pick clubs? That's hard to draw. I'm just going to erase that. Yikes. Or if I did it the other way and I did 2 clubs and 3 hearts, right? So order matters. That's why you can think of it as 4P2. Both of those numbers will give you 12. So we're going to do 12 times all of those percentages, or all of that probability. All right, I know this is not the most interesting, but does anyone have any questions? All right, let's move on. Next page. My other class loved this page. We're doing some Venn diagrams. They were really excited about the Venn diagrams because it was super easy. You can get all in your head about Venn diagrams, so let's keep it as simple as possible. Let's keep it as basic as we can. In this example, I've got 30 students in a class, and I have asked them whether they like M&Ms or whether they like Twix. Okay. Let's just start answering questions, and that will start leading me to like what the parts of this Venn diagram are. How many students like M&Ms? Why is it 17 and not just 11? What do those 6 in the middle represent? They're like both. So if I just say who likes M&Ms, and if you like both M&Ms and Twix, you'd still raise your hand if I said who likes M&Ms. So that's 17. Now, how many students only like M&Ms? That's 11. There we go. Okay. And how many like both M&Ms and Twix? 6. Okay. How many like M&Ms or Twix? If I said raise your hand if you like either M&Ms or Twix, how many hands would be up? What'd you say? 20? Where'd you get 20 from? Each side? What about the kids in the middle? Don't they get to raise their hands too? Because it says you like, if I say if you like M&Ms and Twix, raise your hand. We also want the 6 kids in the middle. What sometimes happens though is that we double count them. You're like, oh, well, there's 17 over here and there's 15 over here, so I'm going to add 17 and 15. No, those 6 kids don't get counted twice just because they like 2 candies. They still only get counted once. So I'm thinking of it as 11 plus 6 plus 9. Not just each side, all of the numbers. And that is 26. So if I said who likes M&Ms and Twix, 26 kids would raise their hands. How many kids like only M&Ms or only Twix? That's the 20 I want. So only one or the other, not both. That's the 20 that I'm looking for. And then how many likes neither candy? 4. Where'd you get 4 from, Kate? Good. We did the whole number of students we had minus the kids accounted for the candy, and I got 4 were left. All right, that wasn't too bad, was it? No. Okay. I love it when they give us a Venn diagram. Now, the next few we're going to do, though, we have to build the Venn diagram. Yikes. This question says, each of the 28 students in the class either like jazz music, country music, or both. Draw a Venn diagram showing the following. How many students only like jazz? 18 students like jazz, 14 students like country. Why can't I just write 18 and be done and move on to the next question? They literally told me. Why is it not just 18? Good. Of those 18, there's some crossover with jazz and country, so we got to figure out how many that is. Okay. My first question then is how many kids like neither jazz or country? Since the silence tells me that we're not sure, I want to ask then, does it say that any like neither music? No. So we're going to say there are no students that like neither. It says they like jazz, it says they like country, it says they like both, but it doesn't say that there's any kids that also like neither of those types. So we're going to say that there's 0 out here. Okay, there's 0 that like nothing. There's a total of 28 kids in this class. So 28 votes must be in this like area right here. How much is 18 plus 14 though? 32? So I've got 28 kids and 32 votes. What's the overlap? How many more votes do I have than actual humans? 4. Again, I'm going to say it again. I want us to keep it simple. 4 is the overlap that is both jazz and country. So my votes minus my actual humans is going to be 4. And so 4 is the overlap. That's who likes both. If 4 people like both, how many like just jazz? Did I hear it? 18 minus 4 is 14. And how many like just country? 10. My question said, which students like only jazz? We're going to say 14. Now, once we built this, I could ask more questions following up, but at the end of the day, it says, this is how many students like it. That's our answer. So all of these are not percentage or probability. They're all just like how many of each student, how many students, how many students, how many students. This next one, we're not going to just find how many students. We're also going to find probabilities. And remember that probability means that we're doing success divided by total. So just something to think about in this problem as we say success, as we say probability, that's success divided by total. Okay. I'm going to draw a Venn diagram. I'm going to draw one up here so that I've got room to do work down here. You can do it wherever you want. Now I'm going to draw a Venn diagram. And this Venn diagram is going to have 3 circles because it's talking about kids liking different types of cars. They like Fords, they like Buicks, they like Chevys. These are kind of interesting cars that we picked from, but that's all right. So I'm going to draw circles. I've got a circle here. I've got a circle here. I've got a circle here. I'm not great with Venn diagrams, so as long as you show that there's some overlap for all 3 and for some individually, that's great. And I've got Fords, I've got Buicks, and I've got Chevys. Everyone doing okay so far? Okay. It says a class of 32 students is surveyed as the type of car they like. Okay, I'm gonna write 32 on the outside somewhere to remind myself that all of the inside must add up to 32. I have to account for 32 humans in this. Okay. It says 19 like Fords, 19 like Buicks, 12 like Chevys. That just means I have 12 people in this whole circle. There's a lot of little spaces to fill, so I can't use 12 yet. I'm going to use it in a minute, but not yet. Then it says 5 like all 3. Oh, great, I can use that. I'm going to put 5 like all 3. That's the very center circle where all 3 circles overlap. Then it says 6 like only Fords. Okay, great. I can write 6 in my only Fords box. It says 3 like only Buicks. Okay, great. I'm going to put 3 in my only Buicks box and 2 like only Chevys. Okay. That's all the information it said. Now it's going to ask us questions. Before I even read the questions, we have to figure out these blank boxes. I'm going to call them X, Y, Z. We're going to use some systems of equations to solve this. It looks a lot scarier than it is, but it's really not that scary. We're going to write 3 systems of equations, and it's 1 for each type of car. So the first one is Ford. So I'm going to write a Ford sentence, a Ford math sentence equation that says 6 plus 5 plus X plus Y equals Ford equals 19. I'll write it down here somewhere. I'm going to say 6 plus 5 plus X plus Y equals 19. It's plus, so you can write in whatever order you want. You can write x plus y plus 6 plus 5, or you can do x plus 6 plus 5 plus y. I do not care. That's my fours. Okay, now we're going to do my Buicks. So let's do the Buicks. The Buick circle goes like this. It has 3 plus 5 plus x plus z. So these are all the pieces that make up the Buicks. And again, that adds up to 19. And then my last circle is my Chevys. And that, everything in that circle is 2 plus 5 plus y plus z. Everyone okay with these equations? Okay, now we're going to simplify them so it's just like x plus y equals a number or x plus z equals a number. And then we're going to use systems of equations to simplify. So I've got here 6 plus 5 plus x plus y. So x plus y cannot be simplified, but 6 plus 5 is 11, and 19 minus 11 should be 8. Okay. The next one, it's 3 plus 5. So 19 minus 3 plus 5 is 8, which is 11. So I've got x plus z equals 11. Everyone see how I'm going from one equation to the other? Okay. And then the last one is going to be 2 plus 5 is 7. And when I do 12 minus 7, I get 5. So y plus z equals 5. All right. Everybody cool so far? Now you can combine any number of these, but we're going to end up combining all three of these equations together so that we cancel out all the variables. So I like to do it in two parts. First thing I'm going to do is combine these two. And I'm going to make one of the equations negative, so we can make this one negative. So I've got x plus y equals 8, and then negative x minus z equals negative 11. So I'm combining them together, and I get y minus z equals negative 3. The only reason I did that is because now I'm going to combine it with the last equation, which is y's and z's. Y plus z equals 5. Oh, and I don't even have to multiply. My z's cross out, and I get 2y equals 2, which says y equals 1. I know I did that a little quickly, so I'll leave it up. So I combined my first two equations using elimination, and then I took that answer and combined it with the third one to get y all by itself. Once I know y, I'm going to go back above and fill in y in my Venn diagram, and then I can use these equations right here to help me solve for x and z, because I already have y. I can use anything of these equations to help me find the other ones. Sure. So y is 1. Anyone know what x or z is? Again, if you come back down here and you're like, okay, well, y was 1. So x plus 1 equals 8. X is good. And then y is 1. So 1 plus z equals 5. Z equals. Very good. Thanks, Hadley. So now I've got all my little Venn diagrams covered. And so I am going to use that to find probability of the two questions I asked. The first one says both Chevys and Buicks. So what's the probability that a student chosen at random will like both Chevys and Buicks? Okay, so I want ones that go in the Chevy category and go in the Buick category. The reason I'm physically shading is because I think that helps me keep it straight. because I want anything that's in both of those circles. And what am I going to add together to get that? Or how many are in both circles? Nine, 5, and 4. Everyone okay with that? Last class we just wanted to say 5 because you're like, or sorry, you just wanted to say 4 because they were like, well, 5 is for all of them. I didn't say doesn't like Ford. I just said what like Chevys and Buicks, and that's 9 kids. So I'm gonna do that. Remember, it says probability, so it's not just 9. It's 9 over the total number of students. How many students are there? 32. And if I were to put that in the calculator, see percent, because 9 over 32 doesn't mean anything to me, I would get 28%. Okay. And then it says none of the cars. How do I figure out who voted for nothing or who didn't vote? What are you doing right now in your head, Brooke? Adding them all up. Good. So we're just going to add up all the numbers that we see. So I've got 6 plus 7 is 13, plus 1 is 14, plus 2 is, did I do that right? 14, 16, that's 20, 28. Oh yeah, I did do that right. I got confused at first. 28. So 32 minus 28. You definitely can do that. The problem that people have is they start adding up everything in F, and then they add up everything in B, and then they add up everything in C, and they count like 7 twice, and 5 3 times, and 1 twice. That is too much. Only count each number once. 32 minus 28 is 4. So there are 4 kids that don't like any of these cars. I'm actually going to put that in the corner. And so what's a percent, or what's the probability that a student will like none of the cars? What over what? Good. And again, if I did a percentage of that, it's like 1 over 8, or about 13%. Okay. Can we try another one like that? Let's do another one like that. Let's do the one underneath it. The only difference with this is it's got a little bit bigger numbers. Okay, so it says 68 seniors were asked if they like green, and 43 said yes. Okay, so if I'm going to make my Venn diagram, green is a thing. And it said that we asked 68 seniors. So we have to write 68 on the outside because that's the total number of kids that we're looking at, 68. Now, I don't get to write 43 anywhere yet. That's extra information. The next thing says 23 said they liked purple, 32 said that they liked yellow. Again, I can't do anything with those numbers yet. I'm going to do something with them in a second, but not yet. Now I actually have numbers that I can do things with. Okay, let me put back yellow and purple so I know what my categories look like. So we'll put yellow over here, and we'll put purple down here. Okay, it says 6 liked all 3 colors. So I'm going to put 6 in my center circle. I can get my colors right. 6 goes in there. 11 like only yellow, so 11 go here. 15 liked only green, that goes here. And then 4 only liked purple. So this is the exact same idea. I gotta find my X, Y, and Z. Try and set up your equations. Remember, we just go one box at a time. So I do all my green guys, and they add up to be 43. When I do my green, guys, I'm going to think of that as like 15 plus 6 plus x plus y equals 43. And in the same step, I'm just going to get it simplified. So x plus y equals 15 plus 6 is 21. 43 minus 21 is 22. So that equals 22. All right, now I'm going to do my yellow. So anybody I touch with yellow. So I've got 6 plus 11 plus x plus z. 6 plus 11 is 7. Oh, and that equals, excuse me, yellow is 32. That equals 32. So I have to add 6 plus 11 to get 17, and 32 minus 17 is 15. And then last, I'm going to do purple. And that's going to be 6 plus 4 plus y plus z equals 23. And so 6 plus 4 is 10. 23 minus 10 is 13. That's not a weird me thing waiting for you guys. Sorry, I just didn't have everything together in my head. All right, now we're going to combine our equations again, and we're going to solve. I'm going to combine these by making everything down here negative. So I've got x plus y equals 22 minus x minus y minus 15. Oh, I have too many y's. That should be a z. My fault. Make sure you keep your x, y's, and z's together. It's super easy just to write x and y because we're used to that. But this is negative x minus z equals negative 15. So I've got y minus z equals 22 minus 15, which is 7. And then again, I'm going to combine it with the last equation. So y plus z equals 13. I didn't have to change any signs because I already have my z's opposite. So I get 2y equals 20 and y equals 10. Everyone doing okay so far? Okay. So put 10 in here. So I found y is 10. So green and purple is 10. Okay, now I got to find my x. Y was 10, so that means x plus 10 equals 22. So x is 12. So between green and yellow, I get 12. And then if y is 10, 10 plus z equals 13. So z is 3. So in between yellow and purple is 3. Okay. So my question now says, if a student is chosen at random, what's the probability that he will like at least one color? So is it successful if he likes green? Is that good? Is that one color? What about yellow? What about purple? What about both yellow and purple? What about both purple and green? What about both purple and green? What about both yellow and green? What about, right? Like, how annoying is that? What is not okay for him to like? No colors. So instead of doing all of the yeses, let's do 1 minus no color. How many kids like no colors? What do we do to find that? Let's find all of these things. So 15 plus 12 plus 11 plus 6 plus 10 plus 3 plus 4. I think that's 10. That's 20. I'm adding in my head. Give me 1 second. 20, 35. This is another 15. That's 50. Is that 61? Oh, I'm afraid I messed that up. I got 60 on my other sheet. You guys add it up for me.
Are these congruent?
Yes.
Okay.
Mhm. Is that it? Okay. You had 61 too? Okay, I think I was tripping earlier. I don't know why I got 60. So 68 minus 61 is 7. So 7 over 68. Bye, Jay. Do I need to send an email to someone? Bye. Okay. Yep. I don't know why I had different answer earlier, but all right. And then we could like do this out, but this is the setup, and that's my answer. Everybody good so far? Because the no color is the only thing that's bad. So we did 1 minus the thing that's not okay. Instead of adding up all the things that were okay, we just did 1 minus the one thing that was not okay. All right, we're going to skip 8 and 9. I will probably make a little video about those because I don't think those are as important, but I will teach that to you. We're going to end today. I got about 10 more minutes with you guys with number 10. I got 3 more problems. We should have plenty of time. A little preview, though, of the rest of the year. You guys take a final on the 20th. That's a Thursday if you are, taking the final. The day before, the class period before that, on Tuesday the 19th, Tuesday the 18th, we study, we prepare for the final. And so next week are the last 3 class periods. I'm going to do as much of 9-4, 9-5 with you as possible in class. If I need to supplement, I'll make another little video, but I'm going to do as much as I can in class. On Tuesday, Thursday, we're going to review, wrap up probability. Friday, we're going to take an assessment, a quiz, a test, a quest, something along those lines of everything from chapter 9. It will not be the whole notes are fair game. It's just what we've covered, okay? We're just getting through as much as we can. All right, that's what the rest of the next 2 weeks look like for you guys. Everybody cool with that? Okay? And I have no juniors in my class, so I don't have to adjust what juniors are like, so that's good. I have 3 and F periods, so I'm very thankful they're all in one class, so I don't have to deal with this. All right, so let's look at number 10, A, B, and C. The last type of problems we're doing, we're going to make little probability trees. That is not an official name for them. That's a Miss White name because that's what I think they look like, and probability is what we're doing with them. So we're going to do little probability trees. Okay, I know the type of problem uses probability trees when I've got several different types of probability and there are 2 events that can take place. So it says, if it rains tomorrow, the probability that Joe will do his homework is 40%. If it doesn't rain, the probability of him doing his homework is 10%. Given the probability of rain tomorrow is 30%, find Joe's probability of doing his homework. Okay, so we got probability of raining and we got probability of doing homework. What I'm ending with is what the end of my little probability tree is going to be. At the end of the day, homework is or depends on the weather. And that's not true always. That's just true in this situation, right? So in this situation, him doing his homework is dependent on the weather. So we're going to do our weather first, and then we're going to do our homework. There are 2 things that can happen with the weather tomorrow. It could rain, or it could not rain. Every time we do a probability tree, there's a correct answer, and then it's just not that. So rain, not rain. Homework, not homework. Blue, not blue. Go, not go. I don't know other options that you can have, but like any option, it's this or that, this or that. Now, for either whether it rains or not, he has another choice, and that's homework or no homework. That happens if it rains. It also happens if it doesn't rain. So I've got this little sideways factor tree. You can make it up and down if that makes it happy for you. That looks like a factor tree to me, so I like to keep my trees looking different. On the little branches, we're going to write the probability of that happening. Okay? So the first probability we read is that if it rains, the probability that Joe will do his homework is 40%. That goes right here. That goes, if I followed along, okay, it rained and he's going to do his homework. That goes right here, and that is 0.4. We're always going to write it in decimal form. 0.4, 40%. Okay. Then it says if it doesn't rain, the probability of him doing his homework is 10%. So I'm going to follow does not rain but does homework, and that means right here I'm going to write 0.1 for 10%. Everybody follow along so far. This structure is just what helps us get the answer, so I want to make sure we're following along. Okay, before we do anything else, let's find the probability of it raining and him not doing his homework. If it rains, he has a 100% chance of doing something, right? 40% is homework. What's the rest of the percentage? 60, right? I thought I heard 60. Or I'm making it up, or the ghost is helping me. So 40% he does his homework, 60% he doesn't do his homework. What about if it doesn't rain? What's the probability he won't do his homework? 90.9. Okay. Now, the last part is the question. It says, given today, like today or tomorrow, the probability of it raining is 30%. We're going to put that for my rain category, which means what percentage is it not going to rain? 70. And we want to find the probability of him doing his homework. So we are successful when we end with homework. And we have to take all the paths that get us to homework, okay? So one path that could get us to homework is it rains and he does his homework. Because both of those things happen and both had to happen for it to be true, one situation, we're going to do 0.3 times 4. So it rained and he did homework. And that's like one situation. Is it rained and he did homework? That's one thing that happened. I'm going to multiply those together. The other situation is that it could not rain and he still does his homework. So you have to get all the way to homework as many times as we can. So we had to take both paths that's got us to homework. So not raining is 0.7, and we times that by the 1%, or sorry, the 0.1 that he will do his homework if it doesn't rain. Whatever the answer for those two are, we're going to add them together. So 0.3 times 0.4 is 0.12, and 0.7 times 0.1 is 0.07. We're going to add them together. 0.12 plus 0.07 is 0.19, which is 19%. So given that it's 30% chance that he will, that it will rain tomorrow, he will do his homework. There's a 19% chance of Joe doing his homework. Okay, let's do another one. Any questions yet? Okay, I'm gonna try and squeeze these last two out. If the cafeteria serves noodles, then there's an 80% chance they'll serve salad. If they don't serve noodles, there's just a 50% chance they'll serve salad. Given that they serve noodles just once a week, once a school week, find the probability they will serve salad. What am I ending my thing with? Noodles or salad? Salad. So I'm gonna make a little tree. It's gonna go noodles, no noodles. And it's gonna go salad, no salad, salad, no salad. All right, let's fill it in. If they serve noodles, then there's 80% chance they'll serve salad. So right here, I followed noodles, I went to salad, 0.8. What's the percentage that they'll serve noodles and no salad? 0.2 or 20%. Good. Then it says if they don't serve noodles, it's just 50% chance that they'll serve salad. So no noodles and salad is 50% or 0.5. What is it for no noodles and no salad? 0.5 again, 50%. And then it says they serve noodles just once a school week. One out of how many times? 5. That's about 0.2. So yes, noodles is 0.2. What's the probability of no noodles? 0.8. And now we want salad. We want yes salad. So I'm going to follow all the roads that go to salad. So it could have yes noodles and yes salad, which is 0.2 times 0.8. And And I could also go no noodles and yes salad, which is 0.8 times 0.5. Multiply, add them together. About 56%. All right. Let's see if we can squeeze one more in, shall we? Let's go. All right, this is talking about probability of lacrosse and soccer. What is my thing going to end on? Is it going to end on soccer or end on lacrosse? Lacrosse, because that's what the ultimate question is. So that means my first option is soccer or no soccer. And my second option is lax or no lax. It's a bummer the lax bros aren't here for their problem. It's a good thing my soccer girls are here because there's a situation for you and for people who do no lax and no soccer. I was no soccer and yes lax, so that's where I would have fallen in this. All right, let's put our percentages in. I've got probability that they play lacrosse if they play soccer is 62. So yes soccer, yes lax is 0.62. No soccer, yes lax is 0.48. So we're going to minus those from 1 or from 100 minus 62 is 38, so 0.38. And 100 minus 48 is 0.52. Probability of yes soccer is 0.7 and no soccer is 0.3. And so we just follow the road to lacrosse. 0.7 times 0.62, 0.3 times 0.48. Add those numbers together. I'll finish it on here, but we'll pray together, okay? Full of grace, the Lord is with thee. Blessed art thou among women. Find a seat, guys. Find a seat. Will, I'm going to make us all wait till you find a seat. Picture you too. Amen. Wait. Okay. I don't know. I thought it was more important. Bye, guys. Have a great weekend. I'll see you on Tuesday. All right, let me finish this problem. 0.3 times 0.4.
Thank you.
Bye, guys. Thank you. And add them together. 0.578 or 58%. I will do number 8 and 9 later, so check out those at a later time. Let me stop my share. Let me stop my record if I can.